Okay, video 20, function notation. So our essential question, what is function notation and why do we use it? So recall from our previous video, y equals mx plus b. What is this form of an equation called? Okay, hopefully you remember previous lesson. This is called slope-intercept form. And we can take this form and then rewrite it into a different kind of notation, which is called function notation. What function notation does is it changes the y into an f of x. What this allows us to do is see what our variable is and the type of function, and that it is a function. So we've got a function that my variable is x, and it's just another name for y. So that whole thing together, f of x, is exactly the same as y. So you would read this as the value of f at x, or f of x. Mostly what we're going to be doing with this notation right now is just finding some values and using it. Its main use is with applications where each of the variables represent something. The f part would represent something, and the x would represent something. So, for example, if I had v of t, v might represent velocity, t would represent time. So what is my velocity over a certain period of time? So here's an example. What is the value of the function f of x equals 2x plus 12 when x is negative 8? Okay, so here my x value is negative 8. So that's f of negative 8 equals 2. My x is negative 8 plus 12. Now let me point something out right here. You are not going to do anything with this negative 8 on that side. That you don't do anything with it. That just tells you what you are substituting in for x. That's all this does. There is no operations here. So that's f of negative 8. That's telling me that my x value is going to be negative 8, so I plug it into the equation, and then I evaluate the right-hand side. So order of operations, we multiply before we add. Negative 16 plus 12 equals negative 4. So my f of negative 8 is equal to negative 4. Now what this also tells me is what my ordered pair would be. Remember, the negative 8 represents x. Remember, the f of x is equal to y, so that means my negative 4 is equal to y. So then I could write an ordered pair from that. So x is negative 8, y is negative 4. So those mean the exact same thing. Okay, next example. For the function f of x equal to negative 2x plus 4, find the value of x so that f of x is equal to 16. Note, we're told f of x is equal to 16. So it's the entire f of x. So when we substitute, we're going to substitute the entire f of x with the number 16. So let's look. F of x equals negative 2x plus 4. Remember, the entire f of x is equal to 16. So we're going to replace the entire thing with the 16. Remember, it's the same thing as saying y. F of x is the same as y. F of x equal to 16 is the same as saying y is equal to 16. We replace the entire f of x with 16. And that equals negative 2x plus 4. Then we solve that equation for x. So we subtract 4 on both sides. 16 minus 4 is 12 equals negative 2x. 4 minus 4 is 0. Then we divide both sides by negative 2. And we get x is equal to negative 6. So that's what we're trying to find. What is the value of x? So that's the same as saying x is negative 6 when f of x is 16. And then again, you could write that as an ordered pair. So that would mean -6, 16, because the f of x is the same as the y value. But this is the answer to the question where it says find the value of x, and x is equal to -6. We have some practice for you to do, so remember, hopefully you took your notes on the right-hand side of your notebook, and then on the left-hand side of your notebook, you will do each of these problems. The first set is like our first example. I give you an x value. You need to find the value of the function. In part B, I give you the value of the function, and you need to find the value of x. And I will be checking these next class, and then we will do some more practice.